If a wrench is turned a quarter turn applying a constant torque of 35 meter Newton, how much work was done turning the wrench? So we know that work for rotation is torque times angular displacement. We're describing a wrench. Maybe I'm turning it like this, right? Quarter of a turn. Something like that. So it winds up here, right? And that, I think, corresponds to an angle of pi over 2, right? In other words, a quarter of 2 pi is pi over 2. So that's the one piece of information that was not explicitly given to me as a number in this problem, but now with the 35 meters times Newton times pi over 2, which I'm just going to leave without units because the radian doesn't really add any dimensions to things. So I can now go to my calculator and have it do 35 times pi over 2, and it gives like 54.97787, etc. And at 3 sig figs, I think that would round off to 55.0. And units-wise, since we're calculating a work, I think now I can go ahead and turn that meter times a Newton into a joule. Since we are doing work, it is okay to use a joule. Even though technically, I've said before, it might be okay to use for a torque. It's just traditionally not done because joule is kind of attached to work and energy. Conceptually, it's named after James Prescott Joule, after all, who was one of the big names for the year 1847 in terms of establishing how energy really works. So that's kind of maybe the history as to why we do it that way, but there it is. That's the answer, 55 joules.